Okay, so second part of the example, we need to sketch this cubic graph here. So f of x equals minus 2 and the brackets x minus 3 to the power of 3 plus 2. So what does that mean, guys? That's negative the coefficient of the x cubed, which is, it's gonna end up finishing down, isn't it? So roughly, I'm just guessing, we can guess this one roughly like that. It's going to finish like this. Okay, instead of going up, we're going to go down. Okay, now this one is telling us it's going to the right by 3. It's going to the bonus 3, and it's going up by 2. So there's a rough shapes we just got. Now before we do anything, it is really always a good idea to find x-intercepts. Okay, x-intercept when y equals 0. Okay, and then of course you have to find y-intercept as well when x equals 0. So if we substitute when y equals 0, what do we get? And when x equals 0, what do we get for y? Okay, so roughly, let's have a look if I can do this on this side. See, when f of x equals 0, which means y equals 0, yeah? So I'm going to push this on the side, and let's see, minus 2 x minus 3 cube plus 2 equals 0. And I'm going to move that to other side, and then I'm going to divide it by minus 2 on both sides. I will get x minus 3 cubed equals 1. And of course, if I cubic root of 1, I'll just get 1. Okay, that's not a big deal. And then therefore x equals 4. So my x-intercept will be 4 when y equals 0. Okay, so that's y equals 0. Now I'm going to push up a little, and I'm going to see what my y-intercept is now when x equals 0. Okay, when x equals 0. So that will be a lot easier for us. Then x-intercept plus 2 equals y. Yeah, so we put the x equals 0, yeah? So that will be y equals minus 2. Now, minus 3 to the power of 3 is minus 27 plus 2. Use your calculator. You will get 56. So when x equals 0, y value is 56. So we got that. So I'm going to put this into some coordinates form. There, and 0, 56. So these are the 2 points these graphs will pass through, this one and this one. Okay, so now I'm going to go make a little bit more room here, and I'm going to sketch this. Okay, again, I'm doing it very rough. You need to do using ruler and a little bit of a scale. I mean, I wouldn't really worry about too much of scale on this part because it's go up to 56. Maybe if it's a scale, I would say go up by 10, 2, 3, 4, 5, 6. So 10, 20, all the way to 60. So 56 will be roughly here. Yeah, and then you don't have to have the same scale of x-axis and y-axis. So I'm going to go 1, 2, 3, 4. Going to go like that. Something like that. So we know this is going to come down. Remember, this has to be. And then it's coming down. It's going to hit the 56 and then going down to here, right there. Okay. Now, what is a point of inflection? we need to find out the inflection points there. So let's have a look first with the 56. So I'm going to put that in. I'm going to use a different color. So I'm coming down from here, down here. Okay, didn't look that nice, but that'll do. So now this is coming down, and I could just make a little bit too obvious. So that will be my point of inflection here, okay, because that's where the concave is changing. This is concave up, this is concave down, and that's where the middle point is, a point of inflection there. So we need to find that, okay. Now if you think about it, okay, if you think about it, it was going up by 2, right? Going up by 2, and it was moved to the 3, wasn't it? So, okay, my graph is not as good because it was supposed to be, it shifted to the right by 3, isn't it? So that means this one should be 3 here. So my 3, and then it's gone up by 2. So the inflection point is depending on these. So where it moved to the right by 3, gone up by 2, that's my point of inflection. Okay, so if it was the other way around, if it was x plus 3 minus 2, it means it moved to the left by 3, down by 2. Your point of inflection will be minus 3 and minus 2. Okay.